Hello everyone, I'm excited to welcome you to the online course Easy Geosteering. Here we simplify the complex geosteering topics, breaking them down into easy to understand parts. We are currently in the third part of the course, Geosteering Tools. In the previous video we learned necessary input data for modeling, and today we will explore cross-section coloring, an important aspect of visualizing the geosteering model. Let's get started. So let's take a look at our example from the very beginning of the course. We already know what a structure map is, we understand the main functions and requirements of offset wells, and we're also familiar with LWD curves in typical heterogeneous formations. Now let's move on to the geological cross-section. First, we can see the segments into which the geological cross-section is divided. Each segment has its own dip angle, and it is the responsibility of the geosteering engineer to split the section and adjust dip of the segments. We can also see the colorful representation of different layers, and in this lesson we will explore it in detail. So, the basis for coloring is a specific offset well log, and in general, coloring can be done using any offset curve. One of the most common options is gamma ray. Let's take a look at its palette from our example. The main idea behind coloring is very simple. We assign a specific color to a certain gamma ray level. Here we have it in microrangens per hour. As we learned in video number 12, hard carbonate layers have the lowest gamma ray values, and here we will color it in light blue. Then the middle gamma ray values correspond to sandstone in the target layer and will be colored in yellow. Transitional values will be shaded in blue-yellow depending on the carbonate content. And the highest gamma ray values correspond to shale formations, which are represented in gray and dark green. Between shale and sandstone, we have transitional values for siltstone. With coloring by gamma ray curve, there is a nuance. As we know, gamma ray alone cannot distinguish between hard layers and coals. This means that in this palette, both coals and hard layers will be colored in the same light blue. We just need to keep this in mind. Okay, the other option is coloring by the density curve. One of the main advantages of this method, the ability to distinguish coal from hard layers. They are on opposite sides of the scale. Coal has the lowest density and is colored black, while hard layers have the highest values with the blue color. In order of increasing density, the sequence follows sandstone, siltstone, and shale. Most often, coloring by density is more informative, but this curve is not a common type of logging in offset wells. That's why gamma ray based coloring is more frequently used. Okay, we have explored two palettes, but in general, coloring is not strictly necessary. We can work even without it. But with proper coloring, work with the cross-section becomes quicker and easier. What does mean proper coloring? It's when each formation in the offset well is assigned its own distinct color. Let's return to our example. Well, to check if the coloring is correct or not, we need to look at the offset curves, identify all formations in it, and verify if the layers have their respective colors. Let's start with the target layer, which is between the red markers. Sandstone on the cross-section has a yellow color, and that's correct. At the bottom of the reservoir, we have sublayers with slightly higher gamma ray level than in the target, and we might suppose it to be a siltstone with yellow-gray color, and that's also correct. At the top we have shale with high gamma ray, and it's also properly colored gray. Under the shale formation we have a sublayer with the lowest gamma ray in the section, which we might assume to be a hard layer. Of course, without neutron density we cannot be sure, but if it's indeed a hard layer, it's also properly colored in blue. So, in the offset well we have 4 different formations, and each has its own color, and this coloring we call proper. But what if one of the sliders has an improper position on the scale? Just for experiment, let's move one slider to the left from 7.6 to 5.8, expanding the target zone. Since our hard layer has 5.9 microrangens, it will turn yellow, and visually it now looks like sandstone, which is not correct. Okay, let's return to proper coloring and try one more experiment. Now we move another slider to the right from 8.3 to 11. All sublayers below the top of the target have disappeared, and now it looks that we have an ideal, very thick homogeneous space zone under the top target, which is not true. So these examples show that we shouldn't rely solely on the coloring of cross-section. We always need to check if it's correct or not by analyzing the offset wheel curves. Alright, we have covered cross-section coloring. Hope you liked this video. Remember, you can take your geosteering skills to the next level with the private lessons. Together we will work in StarSteer to apply all modern geosteering tools and drilling simulators, which immerse you to a realistic scenario. So stay tuned and give this video a thumbs up. In the next lesson we will continue with the first geosteering method or model method. See you then. Bye bye.